just about I and all. Do you have any idea about I, Manvi? Iota?
Ma'am,
Yes.
um, I'm not sure exactly.
Okay, not sure. Just okay. So the basic already I have explained. Let's see whether it is making sense or not. Otherwise, please ask the team to arrange a class. So yeah, we are we were discussing that any number which is in the form of a plus ib, that is called complex number. Now what is I? You all know that I is iota, and that means under root minus 1. So if we are having 2 plus 3i or I into 3, that is a complex number. If we are having 5 plus 6i, that is a complex number. Okay, you are not going to relate it with real number, that why it looks like that. Just take it as it is. It's a complex number. This is the format given by our mathematician. So this is how we'll be writing the complex number. A plus ib format, that is the general form. It one of the example is 2 plus 3i, or maybe another is 5 plus 6i, or maybe you can have 5 minus 7i. Okay, a plus ib format, that is how we write the complex number. Now in last class we were doing so many questions. We were writing the given number in the standard form of the complex number. I would take few more questions from there. Suppose I am taking a question. Second, suppose I am taking a question that is 2 plus 8i plus 7 minus 6i. Okay, an expression something like that is given, and you have to write it in the standard form of the complex number. So what you will do, you will just open both the bracket, and you will just add. The way you deal with algebraic expression, you just do the same thing. Okay, you have to just add this 2 with 7, and you will be having 7 plus 2 9, and you have to just do the simplification of this 8i with 6i, and you will be having 8i minus 6i will be plus 2i. And this way, what are we trying to do? We are trying to simplify the given expression, and we are trying to write it in the standard form of the complex number. 9 plus 2i, we are done with the standard form, that is a plus bi. If anybody will ask what is a, what is b, so we will say a value is 9 and b value is positive 2. Now what is I, that I had explained in the last class, Manvi. So let's continue from here. That yes, Abdul, are you getting this much? Are you getting?
Yes, teacher.
Okay, if not, then in the next doubt clearing class I'll clear these things. Okay, so yeah, we are trying to write it in the standard form of the complex number. You can also have the given expression like this, that is 8 plus 7i whole square, and the question will be simplify it and write it in the standard form, that is a plus bi. While dealing with this type of expression containing I, that is imaginary unit, you can just treat it like any algebraic expression. The way you were using the formula in polynomial chapter, the way you were doing the expansion of, if I will give you, let's say 8 plus 7x whole square, how you will expand it quickly by using the x plus y whole square formula. Similarly here also you need to expand it by using x plus y whole square formula. You'll be having x square plus 2xy, 2 into x into y plus y square. Okay, 8 square will be 64. 8 2 times 16, 7 times 112 I, and here we'll have 49 I square. Now we are trying to write it in the form of a plus ib. a plus ib. Okay, and we know I value is under root minus 1. I value just like pi is 22 by 7, pi is 3.14 approximately. Similarly, I is under root minus 1. Okay, and I is square, when we will do the squaring of I, it is just minus 1. So here, wherever we will see I is square, we will drop the value. Why not we are putting the value of I? Because we are trying to maintain the standard form, that is a plus bi. Bi is there over there in the standard forms. That's why here we are going to leave this I as it is. Making sense? So 64. Okay, I am not going to disturb. I will not say that I will be under root minus 1, because a plus bi format we are trying to generate. At last, our answer must be in this form, a plus bi. So I must be there. I'm not going to disturb this I. Yeah, I square value I will put as a minus 1. Making sense to everybody?
Yes, teacher.
Okay, we'll have 64, we'll have 112i, we'll have minus 49. Now I'm telling you, just treat it like algebraic expression and do the addition of the numbers with number and the terms containing I with the other term containing I. So 64 minus 49 will be doing 15 plus 112i. This way, what we have done, we have created the standard form of the complex number, that is a plus bi. Clear so far?
Yes, miss.
Okay, now I'll take a question which is really okay. When you will see the question, you will feel like how to do this type of question, how to write it in the standard form. So just a moment, let me take those type of question as well. So if we are having, let's say, okay, first let me take this question. If we are having 1 minus I to the power 4, okay, we have to write it in the standard form, that means a plus ib format. Now what you can do, you can again use the all those formula, the formula which you were using in the polynomial chapter, x plus y whole square formula, x minus y whole square formula, x square minus y square formula. Okay, and many more. All those formula we can apply over here. But first of all, power 4 we are having, we can write it as a 1 minus I square and then again is square. Can I write it this way? Power 4, can I write this way? By using law of exponent, yes or no?
Yes, ma'am.
Okay, we can write it. Now, what we will do, we will expand the curly bracket, the inside part. So when we will expand by using that algebraic expression formula, okay, x square minus 2xy, 2 into x into y plus y square, and their square we are having. Now just now I was telling you, if you have not attended the first class, if you have attended the first class, you know I is under root minus 1, and much more important than this result is I square is equals to minus 1. These two results are really 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 important. First one is not that important, but the second one is really 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 important. Okay, so here also we can see I square, we will drop the value minus 1. Okay, I 1 square will be 1, and here minus 2 into 1 into I will be minus 2i. Just we are treating this I just like x or y. Okay, and we are going to do the square over here. Now you will see that 1 minus 1 just cancelling each other, and inside the curly bracket you are getting minus 2i. That's square. When you will do the square of minus 2i, you will be just treat it like algebraic expression, the way you, how easily and how comfortably you do the squaring of minus 2x. If I will tell you please do whole square of minus 2x, you will not hesitate and you will say it will be 4x square. Yes or no?
Yes, ma'am.
Similarly, I'm telling you to treat this I just like that. Okay, and here also we'll be having 4i square. Now wherever we will see I square, we will put the value minus 1, because this result is really important. I value we will not put. Why? Because we want the standard format, that is a plus bi. That's why I we will not touch and I we will not disturb. But I square we will put the value. So 4I square we are having. So 4 into minus 1 and the result is minus 4. But we are supposed to write it in the standard form. That is a plus bi format. So we can say minus 4 can be written as minus 4 plus 0 into I. Are you understanding?
Yes, ma'am.
And this is our standard form of the complex number. Abdul, are you getting it?
Yes, teacher.
Manvi, apart from the fact that from where this I came and what is this I, are you understanding the steps and what are we trying to do over here?
Yes, ma'am.
Okay, so this is how always expression, like any expression will be given, and we will try to write it in the standard form of the complex number. Okay, now let's do a few more questions. Here we are also having, yes, you need to copy these things. Okay, please copy it. Last day also I have not given you time, and I have not got the time to share the PDF as well. Okay, so yeah, please copy it. PDF I will share. So yeah, if I'll share the PDF, then you will be getting this all, right? Okay, so yeah, can I move? I'll be sharing this PDF to you. Can I move, or you want to copy?
Thomas, can
Yes.
you send
Yes.
PDF?
If you're sending the PDF, that's fine. We can move.
Okay, I'll send the PDF today only. Yes, Manvi, when I'll send the PDF, you will be able to understand what I'm talking about. Okay, not completely because explanation is required, but in easiest way, I have tried explaining all these concepts over here, which is there in this PDF. Okay, Abdul, you will be understanding because with you, we were discussing the initial how to find I to the power 3, how to find I to the power 4, how to find I to the power 5. We were discussing in the first class, right, Abdul?
Teacher.
Now, if we are having the next question, that is minus 2 minus 1 by 3I, that's whole cube. This is the question given to us. And what we are trying to do, we are trying to write the standard form of the complex number. The standard form, a plus bi. Just a plus bi we want to generate. Cube and all we don't need. So we can use the algebraic expression formula. Okay, x plus y whole cube, x minus y whole cube. Those formulas can be applied over here. You can assume that this minus 2 is your x and this is your y. You can assume like that and you can use the formula. If you are not able to recall what was the formula over here, for your clarity I am writing the formula over here. The formula was x minus y whole cube. Formula was x cube minus 3xy in bracket x minus y plus minus y cube. Okay, this was the formula. And you must have seen another version of the same formula, that is x cube minus 3x square y plus 3xy square minus y cube. Okay, either you know the second step or you know the third step, same formula. Yes or no?
Yes, ma'am.
Okay, we are going to use this formula over here. First we will expand it and then we will try writing it in the standard form of the complex number. So minus 2 minus 1 by 3 I we are having, will be writing minus 2 is our x. Be careful. Okay, so you can take minus 2 whole cube x cube. Okay, minus 3 into 3 into x. Our x is, be careful, minus 2 into y. Our y is just 1 by 3i. Okay, because that negative which is in front of 1 by 3, that we are taking as a subtraction between x and y. Okay, so our y is this one in bracket x minus y. So minus 2 minus 1 by 3i minus y cube. So minus our y and whole cube. Is it making sense to all of you? Is it making sense?
Just
Just a second. Yeah, let's continue. So now we'll be doing the simplification over here. After doing the simplification, minus 2 cube will be minus 8. Here we'll have here we'll have 3 into minus 2, that is plus, okay, 3 gone also. So plus 2i, can you see? Is it making sense? Plus 2i in bracket minus 2 minus 1 by 3 I, and here 1 by 3 I whole cube will be minus, okay, 1 by 27, 3 times 9, 3 times 27 I cube. Clear? We'll have minus 8 over here. We will multiply this 2i with minus 2. We will have minus 4i. Okay, you will multiply this 2i. See, just the algebraic expression. Simplification I am showing you. Just treat it like a x. You will be able to do it. 2i multiplied with this minus 1 by 3i. Okay, I will be I square. And this 2 into 1 by 3 will be 2 by 3. Plus or minus. So one is positive, another negative, minus. Okay, and here you are having minus 1 by 27 I cube. Now wherever you will see I square, you just need to put the value minus 1. I you are not going to disturb. I you are not going to disturb. I square you will put the value as a minus 1. So minus 8 minus 4i minus I square, I am going to drop the value as a minus 1. And what about this I cube? That also we are going to substitute the value over here, this I cube. Okay, I am showing you again, anyone who don't know what is I cube and how to find I cube. See, whenever you know I value is under root minus 1, most of the time you don't have to substitute I value. You know I square is minus 1, which we got just by squaring. Okay, that I square value, wherever you will see I square, you have to put the value. Now you will also get I cube, I to the power 4, I to the power 5, I to the power 6, I to the power 7, this type of I. Okay, this I is iota or imaginary unit. So this I to the power, if you are having any other power, power 3, power 4, okay, exponent is 5, exponent is 6, exponent is 10, 20, 30, 40, 100, 200, if this iota to the power any number you are having, then how to deal with that, that I was explaining in the last class. Again I am explaining it. If you are having I cube, you will always start with I square. Okay, I square you will start, and you try adjusting the power as much as possible. So if you will take I square, then you have to take one extra I over here. See, law of exponent I am using. I cube can be written as I square into I. And now I square value is minus 1, and I we are not going to disturb, we will maintain I as it is. So we will say I cube is equivalent to minus I. Are you understanding? Yes, everyone, are you getting it?
yes, teacher.
Yes. See, Manvi, for your clarity, if you have to find I to the power 4, You can always you need to start with I square. Whatever be the exponent you are trying to find, you should always start with I square and then try adjusting the power as much as possible. If power 4 you are trying to adjust, okay, you are trying to make power 4, then you can write I squares whole square. Now I square value is minus 1 whole square. That means I to the power 4 is 1. Are you understanding? I will also show you I to the power 5. You should always start with I square and then try adjusting the power as much as possible. How? By using law of exponent. Okay, if power 5 you want to make, then already square you have taken, then one more power 2 you can take maximum outside. Okay, the formula was a to the power m to the power n is a to the power m into n. Okay, we are using the same logic over here. Is I square, we must start with I square and then power 2 I have taken. Okay, still power 5 we have not adjusted, so one extra I will be there. Okay, now I square is minus 1 whole square into I. That means the result will be just I to the power 5 is equivalent to just I. Making sense? If you are having I to the power 9, you should always start with I square and then try adjusting the power as much as possible. So 4 power you can take 4 2 times 8. But there 9 we are having, so one extra I will be there. Are you getting it, Manvi?
Yes, ma'am.
Okay, I square is minus 1 to the power 4 into I, and the result will be just I. This way, what are you trying to do? This way we are trying to write any exponent of I. Okay, I to the power 9 or maybe 10 or maybe 20 or maybe 30. This way we will be able to write it in terms of just I, or maybe just a number we will have as an answer. So I cube just now we have seen is equivalent to minus I. See, I cube is equivalent to minus I. At the place of I cube, I am going to write minus I. We don't need to give any explanation. Getting it? Okay, now we just need to do the simplification. We wanted to write it in the standard form of the complex number. We are having minus 8, we are having minus 4i plus 2 by 3, and here we are having plus 21 by 27i. You can see just the number we are having, or maybe just the I terms we are having. That's it. Okay, now we can take number with number, we can add them, we can do the simplification. Minus 8 plus 2 by 3. Okay, the way you were doing like terms together on like terms, okay, we cannot take together. Similarly here also. Okay, and minus 4i we will be taking with 1 by 27i. Here fractional addition and subtraction you have to do, but we are almost there. Okay, if you are comfortable with fractional addition and subtraction, then we are just done. Okay, next step we'll be taking the LCM and all, and we will be done. Let me show you what you have to do. So minus 8 plus 2 by 3. Minus 8 plus 2 by 3. LCM will be 3 over here. You will have minus 24 plus 2. And here this minus 4i plus 21 by 27i. I'm showing over here. Minus 4i plus 1 by, whenever you are having minus and plus like this, it better to write the positive number first. Why? Because you will not get confused whether you have to subtract it, or maybe the bigger number, smaller number, which one is minus, which one is plus. You will not get confused when you will write the positive number at first. Whenever you are having this type of situation, that minus 3 plus something, a fractional number, for doing the calculation, best way to do, write the positive number first, then you will be taking the LCM over here. LCM will be 27. Here we will have just I, 1 into I is I, and there we will have minus 27 into 4, 108 I. No worries, integer chapter you have learned, and when x minus 108x will be there. You will not get confused. It is possible. Minus 24 plus 2 will be minus 22 by 3. And here we are having this term. Okay, just algebraic expression. That way we are doing the simplification. There we will have negative of 107 by 27 I. And here we are having minus 22 by 3. We are done. Okay, this is our final answer. We have already written it in a plus bi format. Our a can be anything, our b can be anything. That means a can be any number, b can be any number. Fractional also, yeah, it can be fraction also. Okay, a and b can be any real number. You can see our answer is this one, minus 22 by 3. This is our a plus b into I. Clear? A plus BI format we have generated. Is it making sense? Yes. Are you understanding?
Yes, teacher.
Okay, let's move. Manvi, are you getting it?
Yes, ma'am.
Now I am going to take the trickiest question from here. If we are having 3 plus I root 5, 3 minus I root 5 over root 3 plus root 2I minus root 3 minus I root 2. I'm going to make this I as a x. Okay, just for the time being when we are going to solve it so that you will be comfortable. Okay, you don't have to do it anytime, anywhere. Just for your clarity, I'm doing it. I'll rub it and will replace it with I. So if you are having this type of algebraic expression and the question says to simplify it, okay, and write it in the form of the standard form, okay, a plus bi, or standard form maybe a plus bx, this type of format, okay, where a and b are a number. Then what you will do, you will try simplifying it. The numerator, are you feeling that it just looks like a formula, x plus y and x minus y? Getting it? X plus y, x minus y formula, can you see in the numerators part? Yes or no? Yes or no? X, same x. Okay, y, same y. One is addition, another subtraction. Can you see that?
Yes, ma'am.
Have you seen this formula? X square minus y square formula is x plus y in one bracket and x minus y in another bracket. Or maybe the same formula you must have learned like this, a square minus b square is a plus b in one bracket and a minus b in another bracket. Does your numerator looks like that, the RHS part of the formula? If it looks like that, then we can use the formula. We can say it will be 3 square minus x root 5. I will replace this x with I. Okay, just you to be comfortable, I have written x over here. Is it making sense, the numerators part? And let's work on the denominator also. So we are having root 3 plus root 2x. And here, let's open the bracket. Both are in subtraction. So minus root 3 plus, okay, x root 2 or root 2x, same thing. Making sense? Now clearly we can see the denominators root 3 gone. And what are we left with? So the denominator is, the numerator is 9 minus x root 5 whole square will be 5x square. Making sense? And the denominator will be root 2x plus root 2x will be 2 root 2x. Is it clear so far to everybody? Is it clear? Yes or no? Are you understanding, everyone?
Yes, teacher.
Okay, now I'm going to replace this x with I, because we don't have x over here, we have iota. Why I'm taking x? Just you to be comfortable that we are going to treat it like a algebraic expression. The way we add and subtract over there, same way we are adding and subtracting over here. Making sense? Now, here you need to realize we are left with 9 minus 5 I square in the numerator, and the denominator is 2 root 2 I. Now, see, the numerator I square, quickly we will replace it with minus 1. Everywhere we are doing the same thing. Here also we will do. The numerators I square, quickly we will replace it with minus 1. We know iota I, that's the square, is negative 1. We have replaced that. Now the denominator 2 root 2I, we are not able to do anything over here. And what are we trying to get? We are trying to get the standard form of the complex number. Okay, and here in our expression we are having 9 plus 5 in the numerator, 14, and the denominator is 2 root 2I. Okay, 2 7 times 14 you can do, and still you are having 7 by root 2I in the denominator we are having. Okay, the standard form of the complex number is a plus bi. For example, if you are having just 2, you can write it in the standard form as a 2 plus 0I. If you are having just 3I, you can write it in the standard form as a 0 plus 3I. Okay, and if you are having proper numbers, then great, 5 plus 3I. This is also one of the example. Minus 5 minus 2I. This is also one of the example of complex number which is in a standard form. Okay, so sometime you will be having just a number and no I term will be there. That way also you can write it in the standard form. And sometime you will just be containing the I term, 3I or maybe 4I or maybe 5I. That time also you can write it in the standard form. But the expression which we are having currently in hand, 7 by root 2 and I in the denominator. We don't want I in the denominator. We want I in the numerator. A and B can be fraction. Our A and B can be fraction. We can have 1 by 2 minus 2 by 3I. A and B can be fractional term, that is completely fine. But I should not be there in the denominator the way we are having. Are you understanding, everyone? Is it making sense? Yes, Mariam, Manvi, Abdul, Aisha, are you getting it?
Yes, ma'am.
So we are going to use the logic of rationalization. Okay, you have learned rationalization in polynomial chapter, that when you used to have 1 by root 2, how quickly you used to multiply root 2 in the numerator and root 2 in the denominator for doing the rationalization. Okay, if we will have 1 by 3 plus 4 root 2, then how quickly for doing the rationalization you will say that it will be 3 minus 4 root 2 over 3 minus 4 root 2. That way we are doing the rationalization over here. Making sense? Same concept we'll be using in our case. Okay, we will multiply numerator and denominator with root 2 and I as well. Why I? I'm showing you why I. You will understand. If you will multiply root 2I in the numerator, see, I just wanted to multiply I in the numerator and I in the denominator. If you are having any time question like this, 5 by 2I, and write it in the standard form, what you can do, you can just multiply I in the numerator and I in the denominator. This way what you will be getting, 5I in the numerator and 2I is square in the denominator. Okay, wherever you are, you will see I square, just put the value -1. The moment we will put the value I square as a -1, in our example, we'll be getting 5i by 2 into -1. And we will be getting 5i by just 2, -5i by 2. This is the, okay, this one is the answer. You can write it in the standard form, that is a plus bi. You can say your a is 0 and your bi you are having in front of you. Are you getting it? Okay, so what I'm trying to explain that whenever you are having I in the denominator, and if your purpose is to write it in the standard form of the complex number, that is a plus bi, you can multiply one I in the numerator and I in the denominator. Is that allowed in mathematics? Yes, that is allowed. Okay, in rationalization, you used to do the same concept, same thing, and fraction also says multiplying same number in the numerator and denominator is allowed. So yeah, that this is completely acceptable. Hence, we are multiplying I in the numerator, I in the denominator. Due to that, the numerator is containing one extra I, that is completely okay, and the denominator became I square, and we know I square is -1. Clear? Is it clear? In our case also we are going to do the same thing. Okay, something same we'll be doing, but in our case we are going to multiply numerator and denominator with root 2i, because the square root also we are trying to remove from here. Okay, we will not leave root in the denominator, so rationalization. Okay, we will multiply root 2 as well as I in the numerator, and root 2 as well as I in the denominator. Due to that, our numerator became 7 root 2i, and our denominator became root 2 into root 2, only to I square. Is it clear? Yes, making sense? Mariam, are you getting it?
Yes, miss.
Okay. Yes, Manvi, are you getting it? Abdul, are you getting it?
Yes, teacher.
Okay, now we are having the numerator as a 7 root 2i, and the denominator is 2i square, that is 2 into -1. We wanted to remove I from the denominator, and successfully we have removed I from the denominator. Now the final answer is negative sign you can write in the numerator. Your final answer is 7 root 2 by 2i. But this is not the standard form of the complex number. Again and again I am repeating, the standard form is a plus bi, a plus bi, or a plus ib. Okay, so you can write it in that format. You can say your a is 0 and ib you are having in front of you, and this is in standard form where a is 0 and b is negative 7 root 2 by 2. Clear? Is it clear? Yes. Can we move? Yes, Manvi, are you getting it?
Mm. Yes, ma'am.
Okay, let's continue. Now we are going to discuss about multiplicative inverse. Just a second. So do you know, in your lower classes you must have learned that multiplicative inverse of 5 is multiplicative inverse of 5 is 1 by 5. Okay, multiplicative inverse of 5 is 1 by 5. Why? Because such a number, if you are given 5, multiplicative inverse means what number should be multiplied with 5 so that the result will be 1. What number should be multiplied with 5 so that the result will be 1? And we always take the reciprocal while talking about the multiplicative inverse. See, I'm talking about very lower level concept which you have done in whole number chapter, or maybe rational number chapter, or maybe integer chapter. Multiplicative inverse means what should be multiplied so that the result is 1. What shall we multiply in 5 so that the answer is 1? So 1 by 5. What will be the multiplicative inverse of 3? 1 by 3. What will be the multiplicative inverse of 8 by 9? So we are thinking, what shall we multiply with 8 by 9 so that the result is 1? So take the reciprocal, 9 by 8. That is multiplicative inverse. Making sense? Making sense?
Yes, ma'am.
Okay, that's the meaning of multiplicative inverse. The name is saying all about itself. Multiplicative means multiply. Inverse means reciprocal. Inverse means reciprocal. Okay. So, or you can understand in this manner also, with for the given number, what shall we multiply so that the answer is 1? So always we need to take the reciprocal over here. If you understand multiplicative inverse, then today we are going to discuss about finding the multiplicative inverse of the complex number. So if we will have a complex number that is 4 minus 3i, what is the multiplicative inverse of this one? Multiplicative inverse means same. What shall I multiply? Multiplicative inverse means same. What shall I multiply with the given complex number so that the answer is 1? Okay, as we understand, we have to take the reciprocal. Reciprocal, whatever is there, that's reciprocal. Reciprocal means what? Reciprocal means taking the denominator terms in the numerator and numerator in the denominator. That's the meaning of reciprocal. So multiplicative inverse of 4 minus 3i will be 1 by 4 minus 3i. Are you understanding it? Are you understanding it? Everyone, are you getting it? But we are not supposed to leave the answer like that. Okay, the question is talking about, just tell what is the multiplicative inverse of 4 minus 3i, and we will say 1 by 4 minus 3i. Then it will show error, 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 because the format which we have to feed over here in this blank box is a plus bi format. It will only accept this format, answer in this format. Okay, last class and today's class completely we have discussed how to write any complex number in a plus bi form. How to write any complex number in a plus bi form. So if we are saying our answer is 1 by 4 minus 3i, and this box is not accepting this type of answer, it is saying just arrange it properly and then give the answer. So we are trying to arrange it in the standard form. We are going to arrange this 1 by 4 minus 3i in standard form. Are you understanding, everyone? Are you understanding how to write it in a standard form? Just now I was telling you. Okay, use the rationalization concept. Okay, a, how you used to see over there, if a minus b is there, then we will be multiplying a plus b in the numerator and a plus b in the denominator. Okay, same something exactly like that we can use over here. The logic of rationalization we can use over here. What we will say, that if here we will multiply with the 4 plus 3i, and here we will multiply with 4 plus 3i. See, when you are multiplying a number or a term in the numerator of a fraction and same in the denominator of a fraction, this way you are not changing the fraction. Always I give the example that if you are having 1 by 2, and if I am doing the multiplication 3 in the numerator and 3 in the denominator, the result is 3 by 6. Now 1 by 2 and 3 by 6 is the same thing. Why? Because 3 1 times 3 3 2 times 6, it's the same thing. Do you know that? Okay, 1 by 2 and 3 by 6 in lower classes, we are calling it equivalent fraction. So these two are same, okay, equivalent to each other. So when you are multiplying a number in the numerator and a number in the denominator, your fraction looks different, but actually it is same as a previous fraction. Am I making sense to all of you? Yes or no? So here when we are doing the multiplication of 4 plus 3i in the numerator and 4 plus 3i in the denominator, yes, the next step will be completely different. But actually we are not disturbing our fraction. Making sense? Are you understanding? See, when we will multiply 4 plus 3i in the numerator and 4 plus 3i in the denominator, our numerator will be 4 plus 3i. And what about the denominator? Again, x plus y, x minus y. The formula will be x square minus y square. Our motto, our purpose was to write it in a standard form, that is a plus bl. Okay, we were trying to write our answer 1 by 4 minus 3i in a standard form, and that's what we are doing. Okay, in numerator it will be 4 plus 3i, and in denominator it will be 4 times 16 and minus 9i square. I square, wherever we will have, quickly we will put the value minus 1. So numerator is 4 plus 3i and denominator is 16. 9i square will be plus 9. Okay, you are going to have 4 plus 3i by 16 plus 9 is 25. And we are done. We are done with writing it in the standard form. Okay, it can be written as 4 by 25 plus 3 by 25 I. Do you know, in trigonometry chapter in the previous class also, you used to write, if we were having sine theta plus cos theta by cos theta. Have you done something like this previously in previous class? I'm not even talking about in this standard, okay, trigonometric function. In previous class you must have done, we can write it as a sine theta by cos theta plus cos theta by cos theta. Yes or no? Yes or no? Or maybe a basic example, that is, if you are having 2 plus 3 by 5, you can write it as a 2 by 5 plus 3 by 5. Yes or no? Are you getting it? That's how I'm just separating the fractions and writing it in the standard form, and we are done. Now one by one confirm that if you are getting it or not. Our final answer for the multiplicative inverse is this one, in a standard form. Okay, our, which the answer which we have found, that was completely fine, but we are just trying to arrange it in a standard form. There is a direct formula as well for writing it in a standard form. I'll show you the direct formula, but first tell me, are you understanding this step? Just a, yeah, I was about to ask one by one. First tell me it is making sense or not. Abdul, are you getting it?
Not exactly. Not on.
Yes, Abdul, this one, writing the multiplicative inverse, are you getting it or not?
Not it.
Okay, I'll be explaining it to you. Aisha, are you getting it? Yes, Aisha.
No, ma'am, I did not get it.
Okay, so let me explain it over here. Okay, I am telling you that multiplicative inverse of 5 is 1 by 5, right? Multiplicative inverse of 7 is 1 by 7, right? Multiplicative inverse of 6 is 1 by 6, right? Multiplicative inverse of 8 is 1 by 8. Similarly, a complex number you are having, that is 4 minus 3i. Multiplicative inverse of this complex number will be 1 by 4 minus 3i, right? Right? This much is clear to all of you that multiplicative inverse of 4 minus 3i will be 1 by 4 minus 3i. Yes or no?
Yes, ma'am.
Okay, now this way we are not supposed to leave the answer. In complex number chapter, the initial few question you were just learning how to write the given complex number in the standard form, that is a plus bi. That was only just to make you understand that any time anywhere we are not supposed to leave this type of format as an answer. This is not allowed. The way, when you are solving a fraction based question, and if your answer is 24 by 48, you will not leave your answer like that. You will do the cancellation and then you will leave your answer. Similarly, here in complex number chapter, there is a rule that never ever leave your answer like this, the circled one. You have to make it in this format. It is not just for this particular question, it's for all the question which we will be solving in this chapter, that we are not going to leave the answer like that. Now we will try making it in standard form like a plus bi, and we will think what can we do to make it in the format of a plus bi. So the rationalization which you used to do in the previous class, have you done question like this, that if we are having 1 by 3 minus root 2, let's do the rationalization. What we will do, we will multiply numerator and denominator with 3 plus root 2. Yes or no?
Yes, ma'am.
Okay, and due to that, the numerator became 3 plus root 2, and the denominator 3 square minus root 2 square. I am telling you the same logic will help you over here. Exactly the same logic will help you over there, writing your answer in the standard form. So if you are having 1 by 4 minus 3i in the answers part, what you can do, you can multiply numerator and denominator with the 4 plus 3i. Okay, how it is going to help you, let me show you. You are having 1 by 4 minus 3i as an answer, but this way writing the answer is not allowed. So few extra step you are performing. What you are doing, you are multiplying the numerator and the denominator with this one. This way, your numerator became 4 plus 3i and your denominator became 4 square minus 3i square. The moment you are doing something like rationalization, your numerator is sorted and your denominator is also sorted. See, you are going to get a number in the denominator. 3i square will be 9i square. Wait, minus 9i square, like this. Okay, which can be written as 4 plus 3i. In complex number chapter, wherever you will see I square, you have to put the value as a minus 1. Wherever you will see I square, just drop minus 1. So here in the denominator, I can see one I square, I will put the value minus 1. Again, it's not only for this particular question. Anytime, anywhere you see you see I square, just put minus 1. Okay, so we have dropped minus 1. Our denominator became 4 plus 3i by 16 plus 9. That is 4 plus 3i by 25. Now we got the standard form. We can write it as 4 by 25 plus 3 by 25i. Are you understanding, everyone? Is it making sense? See, practice is required over here. If not, then again I'll be taking these things in the next class as well. So, but for now, let me know. Yes, Mariam, are you getting it?